Hey everybody, welcome to another Khan support video. This one is on understanding equivalent ratios in the real world. So let's go through and see if we can get a good sense of this stuff. So I'm going to make this as large as I can make it here. All right. When Arjun makes hot cocoa, he adds 20 milliliters of chocolate syrup for every 3 ounces of hot water. Arjun's brother Eli adds 45 milliliters of chocolate syrup for every 6 ounces of hot water. Which hot cocoa is more chocolatey? Okay, so the first thing to understand here is that we're going to just use uh, equivalent ratios here, and we're going to compare them, right? So we got the milliliters of chocolate syrup on top, and we got the hot water on bottom. You could have picked anything you want, like top and bottom, but since they listed the milliliters of chocolate syrup first, I would put it on top. So what you have is you have mLs of chocolate syrup, right? I'm just going to put chocolate syrup here. And that's going to be a ratio of mLs of chocolate syrup to the bottom, which is going to be the ounces of the hot water, right? So I'm going to put ounces of hot water on bottom. And there we go. So H2O. Okay. So you got milliliters of chocolate syrup to ounces of hot water. Now, obviously, if you're thinking about this ratio in the real world, right, the more chocolate syrup you add for the same amount of hot water, you're going to get something more chocolatey, right? So, in other words, if you got this milliliters of hot chocolate syrup or chocolate syrup on top and ounces of water on bottom, the ratio, the larger ratio, right, where the top is bigger than the bottom, right, or proportionally larger than the bottom, is going to be more chocolatey, right? So that's what we're going to kind of look for, the one that's the larger value, because it's got the chocolate syrup on top, right? So the more chocolate syrup, right, it's going to be for the same amount of water, more chocolatey. So when we're comparing our two brothers here, we've got Arjun. So we'll do Arjun first. We'll do Arjun. And Arjun's situation is that Arjun's going to do 20 mLs of chocolate syrup for every 3 ounces of water. So his ratio is 20 to 3. And we're going to compare this to, over here, his brother, who's Eli. And we're going to say that Eli has 45 milliliters for every 6 ounces. So these are the two ratios that you're comparing. And you're basically asking which one's more chocolatey, so which one has a higher rate of chocolate syrup to, or a higher ratio of chocolate syrup to water, right? Now, one way to compare these is something called a unit rate. And that just means you do top divided by bottom. And that's going to be the amount of chocolate syrup for every 1 ounce of hot water. It's called the unit rate, right? So the unit rate here might be a really easy thing to use. You just do 20 divided by 3 to get the unit rate. So what is 20 divided by 3? 3 goes into 20 how many times? 3 goes into 26 times, so 2 left over. So you would say that Arjun uses 6 2/3 milliliters of chocolate syrup for every 1 unit of water, 1 ounce of water. Whereas Eli over here, 6 into 45, 6 goes into 45 how many times? 6 times 7 is 42. And then there's 3 extra left over, so 3 out of 6 is 1/2, right? So it's like 7.5 for every 1 ounce of water. So now what you've done is basically you've created what are called unit rates, right? And that would be the mLs per ounce of water, right? That's it, per single ounce. So we have our mLs per ounce with chocolate syrup per ounce. This person uses 6 2/3 milliliters of chocolate syrup per 1 ounce. This person uses 7.5 milliliters of chocolate syrup per ounce. So obviously the 7.5 is more chocolate syrup per ounce, which means that they are more chocolatey, right? So Eli is the chocolatey winner, right? His is more chocolatey than Arjun, right? You could also compare these in any other way you want. You could have also just done equivalent ratios and say that Arjun's is equivalent to 40 out of 6, right? I just wanted to go over what a unit rate was with you so you could see kind of that used in the real world as well. And if you compared 40 over 6 compared to 45 over 6, obviously 45 wins. So no matter how you think about it, right, Eli is definitely going to have a more chocolatey drink than Arjun. So it says which hot cocoa is more chocolatey. You would say Arjun is the less chocolatey and Eli is the more chocolatey. So Eli's hot cocoa is more chocolatey. And then you go to the next thing. So now we're going to go down here and make some more space for number 2. All right, so number 2 here. Boop, 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 boop. There we go. All right. It says Victoria's favorite cookie recipe uses 170 grams of butter for every 250 grams of flour. Victoria's daughter, let me zoom out a little bit because it's not showing me everything. Let me zoom in there. Go. Okay, that's better. Victoria's daughter made cookies using 340 grams of butter for every 400 grams of flour. What will Victoria think of her daughter's cookies? Okay, so first thing is let's compare these different situations, right? You got the grams of butter compared to the grams of flour. So on top we're going to have grams of butter. And on bottom, we're going to have grams of flour. So those are the two things that we're relating, right? Because remember, ratio is just comparison of any two things. So we got butter to flour. Now, obviously, the more buttery you want your cookies, the more butter, right? So more buttery, more butter compared to the same amount of flour. So if the butter was bigger as a ratio than the flour, then you have more buttery cookies and so on and so forth. So let's just take a look at this. Victoria is our first ratio we're looking at. Victoria. Write this a little bit nicer for you guys. I know it's a little slower, but I want to make sure that I write it clearly for you. So there's Victoria, and hers is 170 to 250. So 170 grams of butter for every 250 grams of flour. And by writing this out over here, I don't need to rewrite those details here because I already have them, right? So 170 grams of butter for every 250 grams of flour. But then over on the other side here, we're going to compare that to her daughter, right? So we'll just put D for her daughter. And her daughter likes 340 grams of butter for every 400 grams of flour. And so, I mean, obviously, this looks like something we have to kind of compare, right? How are we going to compare it, right? And I'm seeing a couple things, and maybe you guys are seeing it too. I'm seeing 170 is going to compare nice and easily to 340 because I can just double the top and bottom here. So if I make the tops the same, then what I get is 340 over 500, right? Is compared to 340 out of 400. So when we look at that, we can say that Victoria uses less butter. Well, same amount of butter, right? But with more flour. And daughter uses the same amount of butter, but with less flour, right? So the ratio of butter to flour is going to be more buttery for the daughter than it would be for Victoria, right? Because 340 out of 400 is a greater value than 340 out of 500, which means that the percentage or ratio of butter to the whole is going to be greater, right? Because 340 out of 740 would be greater than 340 out of 840, right? So we can see that in this case, the daughter's cookies are definitely going to be more buttery because the numerator is the number of butter, right, grams, and the denominator is the number of flour, grams, and they use the same amount of butter with different amounts of flour. And if you have more flour for the same amount of butter, it's going to be less buttery. Right? So Victoria's cookies are less buttery than the daughter's. So when it looks over here, it says, what will Victoria think of her daughter's cookies? Well, Victoria is going to think that her daughter's cookies have more butter than she likes, right? So would she think that they have too much butter, they don't have enough butter, they have just the right amount of butter? Victoria's going to think her daughter's cookies have too much butter. So because the daughter's cookies are more buttery than Victoria. And that's that. If you wanted to do unit rate again, you could. You could say, what is Victoria's unit rate? 170 divided by 250. Get that unit rate, and then that would be the grams of butter per gram of flour compared to the daughter's grams of butter per gram of flour. And you could compare those two numbers and see that the daughter's more buttery than Victoria, right? But this one was pretty easy to do just by looking at the numerators that were the same and then thinking about what that meant, right? So that's that. Let's move on to the next one. Okay, so I'm going to say that this is more butter there. Okay, let's do the next part. Okay. The Soup Shack usually makes tomato soup with 9 tomatoes for every 12 cups of soup. Today they made 8 cups of soup with 6 tomatoes. So normally what they do is they have how many tomatoes is the top to how many cups of soup is the bottom. So we got tomatoes to cups of soup, and it says normally, so we'll do normally. Normally is the first category, right? Normally they do 9 tomatoes for every 12 cups of soup, so 9 to 12, all right? Which is obviously the same as 3 out of 4. But now we're going to compare it to today, and today they did something differently. So what did they do today? Well, let's write that nicer. Today, they made 8 cups of soup with 6 tomatoes. Well, they made 8 cups of soup, that goes on bottom, with 6 tomatoes, that goes on top. So you have to make sure that, remember, the cups of soup is on bottom, the tomatoes on top. So even if they change the way they write it here, or they said 8 cups of soup, doesn't mean that goes on top. You chose the category of cups of soup to be on bottom, that's what it has to be on bottom. Okay, so you got cups of soup on bottom, you got tomatoes on top. So what we're noticing here is if you made the decimal for this, right? This is the same as 3/4, which is going to be 0.75. This is the same as 3/4, which is going to be 0.75. So what do you see about the decimal value of this ratio for both sides? It's the same, right? Okay, so the ratio seems to be staying the same. Pretty simple, consistent, right? If you simplify this one, top and bottom, what do you get? Well, 9 divided by 3 is 3, and 12 divided by 3 is 4. That's simplified 3/4, 3 tomatoes for every 4 cups of soup. Over here, if you simplify it, divide top and bottom by 2, what do you get? 3/4, right? 3 tomatoes for every 4 cups of soup. So the ratio stays the same. These are equivalent ratios. So when it says here, how does today's soup compare to the usual recipe, you'd say they taste the same. So today's soup will taste the same. I agree. All right, now let's do the next one. The next one says Burger Barn makes dipping sauces by mixing 2 spoonfuls of honey with a half spoonful of mustard. Okay, fair enough. Let's go and write down this recipe for Burger Barn. So their ratio is 2 spoonfuls of honey. So it's going to be spoonfuls of honey, first of all. Spoonful of honey. And we're going to compare that or relate that to the spoonful of mustard. So spoonful of mustard. Okay, and it says Sandwich Town makes dipping sauces by mixing 4 spoonfuls of honey for every 1 spoonful of mustard. All right, so we got these 2 categories, these 2 restaurants. You got Burger Barn as the first restaurant, and we're going to compare that to Sandwich Town. Okay, so Sandwich Town is the other restaurant. And Burger Barn, honey on top, mustard on bottom. Burger Barn uses 2 spoonfuls of honey for every half of mustard, and Sandwich Town uses 4 spoonfuls of honey for every 1 spoonful of mustard. All right, fair enough. And then if you were to, let's say, compare these two and try to figure out, okay, what's the relationship between these 2 ratios that these 2 restaurants use, I think it's pretty obvious to see that they're going to be equivalent, right? Because if you take the one on the left and you multiply top and bottom by 2, what do you get? 4/1. So we can see that Burger Barn and Sandwich Town have the same recipe for their hot honey mustard sauce, that it's basically 4 parts honey for every 1 part mustard. So these are the same, right? So when it talks about which dipping sauce has a stronger mustard flavor, you'd say that they're the same. The 2 dipping sauces taste the same. That's it. And that's how you do the problem.